So hello guys, today we are going to do Leetcode question. The next question that comes for us is sort colors. The question number is 75 and the question is seemingly very interesting. Why is it interesting? You will get to know. You will very soon get to know why is it so interesting. Okay, so let us first read the problem statement as we always do. So what does the problem statement say? Okay, I'll start reading with you. So you also read, I also read. I'll speak and read. Okay. Given an array nums with n objects, given an array nums with n objects colored red, white, or blue, sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. Given an array nums, okay, so what does the question say? You are given an array nums with n objects. N objects means n number of n indices. Okay, n objects, that particular index, that n times. Okay, the object n times. So you are given with n objects that consists of only red, white, or blue colors. Okay, like you are given some items in an array and the question is saying that it is only of either red color, white color, or blue color. You have to sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. Okay, so what the question is saying that you have to basically sort the array such that the colors red, white, and blue are together in this order. Like all the red color comes first, then all the white color comes next, and then the white colors comes last. Okay, so first red, then white, then blue. First, what does the question say? How you have to order? Red, white, and then blue. Okay, and the question is again saying we will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. Okay, so it says you will use the integers 0, 1, and 2. For red you will use 0, for white you will use 1, and for blue you will use 2. Okay, so you have to basically sort the array that consists of only three type of numbers that consists of like only three type of numbers that can be 0, 1, or 2. Okay, you have to sort an array that basically consists of three numbers 0, 1, and 2 in any order. You just have to sort them. Okay, and there's a line given, there's a specification given. You must solve this problem without using the library sort function. Okay, so how is it any different? If anyone says what to do, you just have to, if you perform simple sorting, like I can use the library function, right? Nums dot begin and then nums dot end. So basically, if it is of any order, if it is in the order, if I take the first test case, this one, 202.110, 202.110, and it becomes 0, 0, 0, 0, 0, and then 1, 1, then 2, 2. If I sort it, it becomes like this. If I sort it, it becomes like this. Okay, but I don't have to sort it, because if I sort it, the time complexity would be n log n. Time complexity would be n log n. And what is the question trying to say in the last line is follow up. What is the follow up? If you can observe the follow up, could you come up with a one pass algorithm using only constant extra space? Okay, so you have to do the question in one pass, that is only traversing the array once, and also using constant extra space, that is you can't use any extra space. Okay, so okay, we'll get to that solution. First we'll discuss what the question is trying to say using I'll write in tab. Okay, so if the array consists of numbers such as 2, 0, 1, 2, 0, 2. So I just have to sort it. Numbers can be 0, 1, 2. I just have to sort them in ascending order such that it becomes 0, 0, 1, 2, 2, and 2. So the sorted order becomes this. What can be the brute force approach according to you? If I told you one I told you using the library function. What if I am not using the library function? Brute force without library function. Without library function. Okay, without library function. So that is not in n log n. Okay, obviously. So what can I do if I am given this array that consists of 0, 1, and 2 in any order 2, 1, 0, 0, and 2. Okay, if I am given like this, I can easily say that I can make a map. I can make a unordered map. I can make an unordered map with the values and their frequency, with the values and their frequencies. And what will I do? I'll record each of the numbers frequencies. What does I mean by that? I'll record how many times does 2 come, how many times does 1 come, and how many times does 0 come. Okay, if I record it like here, if I record how many times does 2 comes, obviously by iterating through the array, so if I iterate, if I'm at this position, I'll record 2 as 1, 2 occurs one time. I'm at this position, 1 occurs once. I'm at this position, 0 occurs once. I'm at this position, 0 occurs twice, so it will update. I'm at this position, so it means that 2 occurs 2 occurs twice. Okay, so if I want to sort it, what I'll do is I'll just simply use this array. I'll just simply use this map, and I'll say that I can override this existing array. I can override this existing array. What is my existing array? 2, 1, 0, 0, 2. Okay, I can just override this existing array, and I say that if I have to order 0, then 1, then 2, so I'll just take the frequency of 0. I'll take the frequency of 0. What I'll say? It comes 2 times, so I'll mark it twice in the first. I'll just overwrite it. Okay, 2 comes twice. Then I'll say, okay, then 1 comes. Okay, I'll write once. 1 comes once. 1 comes only once. Okay, so I'll write 1 here. Then I'll check for 2. 2 comes twice. 2 comes twice. So I'll just overwrite the remaining ones. And what I get is a sorted array. What I get is a sorted array. So this can be one approach towards solving the problem. But what is the time complexity? If you see, we are just traversing the array once for storing, one for storing, then the other for one for storing in the map, and one for storing in the array. So what is the time complexity? If I say of the time complexity, then time complexity is order of n plus n. One for storing and one for storing in the map and one for storing in the array. Okay. And if I say about the space complexity, then I can easily see that I am using a map. What I'm using? I'm using a map. And the map obviously takes O of n space. So this is not an optimal solution. This is not at all an optimal solution. So what I'll do? How to make it better? I can obviously not make a map. I'll just obviously not make a map. And I'll just declare 3 variables. One who stores the 0 count, one who stores the 1 count, and one who stores the 2 count. And I can just simply iterate. And what does the iteration will give? What the iteration will give is what the iteration will give is, I can easily store the frequency of 2 in this variable. Okay, 2 occurs once, 1 occurs once, and 2 occurs twice. 0 count would be 2. I can just easily store it in the order of 2, order of 0, then 1, then 2. So 1 comes twice, 0 comes twice, 1 comes once, and 2 comes once. So this is my sorted array. This is my sorted array. But the time complexity in this case would be O of n plus n only. O of n plus n only. Space complexity is O of 1 because I'm just using three variables. I'm just using three variables and storing in them. So time complexity we have optimized. We have let it down from O of n to O of 1. But it is still not good because I just want to solve it in one pass. Currently, I am able to solve it in 2 into O of n time complexity. I am able to run 2 loops and I am able to solve this question. I have came down the complexity from n log n to 2 into O of n. But the interviewer will not be happy with this. Interviewer will not be happy with this solution also, and he'll ask you to optimize it. Okay, so what I can do? If I read the question again, what colors are there? I'll tell you a optimized solution which was given by Digitras. Okay, which was given by Digitras. You must have heard his name. Okay, so if I observe what are the three colors that are given and what is the order in which we have to sort them, it is in the order of red, white, and blue. If I can observe something, red, white, and blue in the order gives me some country's flag. What is it? Yes, Dutch. So Dutch flag is known as Dutch flag. Basically, just have to order in this way: red, white, and then blue. So I basically have to make the Dutch flag constant. Like I basically have to make the order. So I have to make this order. I have to sort in this order that this flag remains constant. Okay. So okay. So so due to this problem is also known as the optimized solution of this problem is known as Dutch national flag algorithm. Dutch national flag algorithm. Okay, Dutch national flag algorithm. So now you know why is it known as Dutch national flag algorithm. So how do I solve it? How do I solve it? What is the optimized approach? How can I do it in O of n? How can I do it in O of n? Let me show you. Let me show you. Be patient. Okay. So suppose I'm given an array, and in this array I'm storing 0, 2, 1, 1, 0, 2, then 0. Okay. Suppose I'm given this array, and the question told me to sort this array. So the Dutch national flag algorithm is based on the intuition that if I declare two variables, two pointers basically, if I declare three variables, low, mid, and high, low, mid, and high, this can be used to solve this problem in O of n. How? So it is an interesting question. How? So if I say that if there are three colors, then if I sort two colors out of it, then the third color would automatically be sorted. Yes, because see, 0 0 0 0 0 and then 2 2 2 2 2. If it comes like this and in between some ones are there, so if I sort zeros and twos, so I can say that in between only one would occur. So this would obviously be sorted. The in between order would obviously be sorted. So if I sort two colors out of three, if I sort two colors out of three, then if I sort two colors out of three, then two colors would be, then all the three colors would be sorted. All three colors would be sorted. All three colors would be sorted. Okay, so easy. Now I know what to do. I have broken down the problem from three colors to two colors. I just have to now solve for two colors. Okay, so what I'll do is, if I take the test case 202.110, 202.110, what I say in this algorithm is, if suppose I am given a way, this is the low one and this is the high one, this is the range, low and high range. Okay, low and high range. Low and high range, I say that low pointer is pointing here and the high pointer is pointing here. Okay, and after this point contains all the twos, and after this point contain all the zeros. So so the remaining range would obviously cover all the ones. So I just have to do at at traversal. What I have to do is, this would be always the unsorted part in the starting. I say that on the left side all the zeros are there, on the right side all the twos are there, and the middle portion always remains unsorted. I have to sort it. I have to sort it. I have to sort this portion only. Okay, and this portion is the sorted part, and this portion is the sorted part. This is under maintenance. Okay, if I draw a clear diagram, what I want to say is, if I divide the question in three ranges, my low points here, my high points here, my mid is somewhere here. Okay, and I say is this part is sorted. This part is sorted by zeros. This part is sorted by twos, and I say that this part is under construction. That means if there is it can, and consists of 0, 1 and 2. That is in between of the question while I am processing. Okay, at last it will contain only ones. At last it will contain only ones. Only once. But as I am processing, it can contain 0, 1 and 2. 0, 1 and 2. Okay. So what I say is, if I encounter any zero, I'll just throw it on the left hand side. Suppose you are in middle of a ground. Okay, you have two walls, one on the right side, one on the left side, and you decide to say, then you have some bags to throw. You can either throw it on the left side, or you can keep them here, or you can throw it on the right side. So if you are said that all the bags numbered 0 are to be thrown on the left side, and all the bags numbered 2 have to be thrown on the right side. So you will pick up the bag one by one and you will see the number, and all the bags numbered 1 should stay in the current location only. Okay, so I'll pick up the bag once one by one, because the bags are heavy. I can't pick up all at once. Okay, so I just pick up them one by one, and what I'll see is, I'll see the number. If the number is 0, I'll throw it on the left hand side. That is what I'm doing. If I see the number and it is 0, I'll just throw it on the left hand side. I'll just throw it on the left hand side. And if the number is 2, I'll just throw it on the right hand side. If the number is 2, I'll throw it on the right hand side wall. Okay, and if the number is 1, I'll just put it back. I'll just put it back. I'd say I'm not given the instruction to do what to do. So I'll just move it, I'll just put it back and I'll continue. Because if it is numbered one, if it is numbered one, you won't hold it that now. You will just leave it because it is heavy. So you will pick up the next one for your work to be done. Because if you are not moving, if you are not putting it back, then you can never traverse. Okay, you can never traverse. Okay, so it is based on the simple intuition that I am basically segregating the things. I'm basically segregating the things. If any zero comes, I'm putting it on the left hand side. If any twos come, I'll put it on the right hand side. So obviously, all the things, all the numbers that would be present in between would be all ones. I think the idea is now clear. I think the idea is now clear. Okay, so I am basically segregating my things. I am basically segregating my things. Zeros to the left, twos to the right. So in between stays what? One. That is my idea of the solution. Okay, so if I basically develop an algorithm out of this, so this middle range would be my unsorted one at any given instance, not at the last one, but at any given instance. It is my unsorted one, and it can have 0, 1 and 2. I have 2 pointers resting here, one as the low and one as the right. I say that the range after when one has high, I'll say that the range after this is sorted and the range of before low is sorted. Okay, so my mid pointer would be starting from the low range. Mid pointer would be starting from here and going till the high one. Okay, so my mid pointer will be starting from the low pointer and will be going till the high pointer and will be going till the high pointer. Okay, because this is the starting, right? If you throw anything, if you throw anything on the other side of the wall, it will be at the like adjacent. It will be thrown at the adjacent, at the very adjacent, right? So I'll just put it. If I find anything, if I find any zero, if I find any zero, I'll tell it to swap with the low one. Okay, I'll tell it to swap with the low one. Okay, because here one can be also present. Okay, so in exchange, basically I am doing an exchange. If there are any zeros, suppose in this only zeros are supposed to be there, but what if there are ones and or twos? Okay, so for every zero, for every zero, I'll just make sure to return one stuff. Like, you can't get or give anything for free, right? So you are basically giving something and taking something. So you will give something to the left hand side. You'll give something to the left hand side. You'll give something to the left hand side, and you take something from the right hand side, from the left hand side. Okay, you give something to the left hand side, you take something from the left hand side. So it's a give and take stuff. Give and take stuff. Okay, give and take stuff. Okay, seems nice, seems logical. Okay, and I'll do the same thing on the right hand side. I'll just give 2 and in return I'll take what the other person has to give me. I don't know what is the number that he is giving, because I can't see the number written on the bag that he is throwing. I don't know. Okay, so if I get 0, I'll throw it and get something in return. If I get 2, if I have 2, I'll throw it on the right hand side and get something in return. Okay, so I can basically derive two things, that if, okay, and I'll throw it adjacent to the wall. That means if I get any 0, I'll just swap my nums of mid. I'll just swap my nums of mid with my nums of low. Why? Because my nums of low at this side and my nums of low will only return, because the first person standing here can only throw. First person standing here can only throw. If he is throwing from out, it will be in his parlor only. Okay, so he is standing right here. If I have to give something, I'll throw to him, and if he wants to give something, he'll throw to me. Okay, so I'll just I'll just have a like give and take exchange between the mid and the low, mid and the low. So if I write it as a pseudo algorithm, if I write it as an algorithm for traversing the unsorted range, while traversing the unsorted range. What does it mean by unsorted range? This range, this in between range. Why is it unsorted? Because it is the left side is sorted and the right side is sorted. This is unsorted for now, but it will also become sorted eventually. Okay. So while traversing the unsorted range, what I can say is, while traversing the unsorted range, if any box या bag numbered, if any bag numbered 0 comes, if any bag number 0 comes, then do swap of nums of low and nums of mid, swap of nums of low and nums of mid, and move my pointer one step ahead, because the transaction is done, because the give and take transaction is done. Now both of the people will be picking up different bags, right? They'll just leave the bag that they got and they'll pick up the next bag. Okay. So I'll just increase both of their counts. They'll both see next bags. Okay. So if any bag, and other case can be if any bag numbered 1 comes, then he puts it down and moves to the next bag, and moves to the next bag and moves to the next bag. What does it mean? Moves to the next bag means I'll just simply do mid plus plus. I'll just simply move to the next bag. Okay, seems nice. If any bag numbered 2 comes, then throw to right side. I'll throw it to right side. What does it mean? I'll just swap it. I'll just swap the middle one. I'll just swap the middle one with the right one, the element present at the right index. That means, as we do in the left hand side, that the person is present here, on the right hand side also the person is present here. Okay, so he can only send and he can only receive. So give and take transaction can only happen between the closest persons. Okay, so I'll just make it happen. I'll just make the transaction happen, and I'll decrease the value of right. I'll just decrease the value of right. Okay, I'll just decrease the value of right. Okay, seems nice. So these are the rules that we will follow. These are the rules that we will follow. Remember, in this case, we are not decreasing the value. We are not decreasing the value of mid here. Why? Because if we decrease the value, I'll go to the bag that has already been put down before. That has been already been put down before. Okay, if that has already been put down before, I don't want to see it again, so I'll not decrement the value. I'll not decrement the value. Okay, high is coming low, that means that high is coming from the right position to the left position. Okay, and my mid pointer is coming from the left position to the right position, so they will collide. At some time. That means my mid is sometimes gonna be equal to high or right. As you can say, it is just a variable name. Okay, so this would be my exit condition of the loop. What will be the exit condition? If mid becomes higher than high, mid becomes higher than high, matlab greater than high. Okay, so this would be my exit condition, because then I'll just then I'll just exchange sides, because if I am going higher, then if I am going greater in position, then if I am going in greater than position in, like, from mid to high, if I go greater position, that means I am jumping the wall and going on the right side, and he is jumping the wall and coming on the mid side. So there is no point of comparing all the elements again. So this would be my ending condition. Okay, what I am doing, if I summarize, we will traverse the unsorted range, if any bag number 0 come, I'll throw it on the left hand side, I'll get something in return. If I get a bag number 1, I'll just drop it. If I get a bag number 2, I'll just swap it with the right hand side. Okay, and the person closest to the wall, on both hand side, can only make the transaction. Person on the, a person closest to the wall on both the sides can only make the transaction. And any of this only can one happen, because I can pick 3 bags at one side. I can only lift one bag at once. So either I can throw it on the left hand side, I can throw it on the right hand side, or I can put it back. What my ending condition would be, when my mid is higher than high, when my mid is greater than high, then this would be my ending condition. So this was all about the Dutch national flag algorithm. This was all about the Dutch national flag algorithm. If I do a dry run out of it, if I do a dry run out of it, 202110, 202110. Okay. So this is my question, and I'll just write the solution. What I am getting is my low pointer stays here, and my mid pointer stays here for the first case, and my high pointer stays here. For the first case, this is the sorted part, and this is the unsorted part. Anything beyond this is the sorted. Anything beyond this is sorted for now. Okay. So if I get 2, what I'll do is I'll just see the middle element. Okay, I'll just see the middle element. So what I'll do is I'll swap it by 0. I'll swap it by 0. Why 0? Because the person that is standing closest to the rightest wall, I'll have to throw it on the right side. The person standing closest to the wall gets the back. Okay. So I'll just swap it, and what I'll get 0 in return, and I'll get 2. Okay. 0, 2. The other array remains same. My low remains here, my high remains here. No, my high doesn't remain here, because my mid remains here, mid remains here, and my high value get decremented. Why? Because he has already seen through that bag, and he'll have to come a little closer to the wall. So he'll decrement the count. My high comes here. Okay, my high comes here. My high comes here. Okay. So what my next step is, okay, okay. Now I'll just again see what is at my mid position. I see that it is 0, and for 0 we have to say that for 0 we have to throw it on the left hand side. Okay, for 0 we have to throw it on the left hand side. So I am throwing it on the left hand side and doing just a swap. So they are on the same position. As they are on the same position, 0 remains 0, 2, 1, 1, 1, 2. Okay, seems nice. I just have to increment my mid pointer, as well as I have to increment my low pointer. My low also comes here, because he'll also take the next bag. Left hand side person will also take the next bag, and I'll also take the next bag. Okay, and also take the next bag. So for the next count, and my high remains here, For the next iteration, what I'll do is 2, 1, 1, 2. Okay. For now, my mid is here, my low is here, my low is here, and my high is here. Okay. So what I'll do is what I'll do is I'll again check what is there on the mid position. So I saw that 0 is present. 0 I have to throw on the left hand side. So again it becomes like this, like nums of mid is swapped by nums of low. Okay, and both the pointers increase. So my nums is my low and my low and my mid is now pointing to this position. Low and mid is both pointing to this position. Now I'll see what is at my mid position. My mid is at 2. So I'll just put it on the right hand side. That is, I'll exchange it with high, because I'll exchange it with the person closest to the wall. Okay. I'll exchange it with the person closest to the wall. I'll just replace it with high. And what I get is 0, 0, 1, 1, 2, and 2. And I'll decrement the counter of high. So my high remains here, my mid remains here, Okay, seems nice. And my low remains also here. Seems nice. Okay. So as you can see that my array is sorted, but the ending condition is not yet achieved. When my ending condition will be achieved, let's see. So if I am now at 1, my mid is equal to 1, nums of mid equal to 1, then in this case I have to put the bag there only. So I am just putting the bag there, and I'm moving to the next bag. So my mid remains here and my high remains here at the same position, and my low remains one step back. Okay, so I'll again check what is at my mid position. My mid position is again 1. Nums of mid is again 1. So for nums of mid is equal to 1, I'll just increment my counter. And now my counter comes here, my mid counter becomes here, and my high counter comes here, my low counter comes here. So what I can see is, in this case, my mid has become higher than high. Mid has become greater than high. So this is my exit condition. Achieved. So the loop will end here. And you can see the array is now sorted. So as you can see, the array is now sorted. That means our algorithm is working. So if I want to code this approach, I'll just declare the size of the array for first. Then I'll declare low pointer as 0. At the initial stage it will be at 0, and I'll declare my mid pointer as 0 and declare my high pointer as n-1. n-1 means at the last position that we saw, right? The first position of the pointers were low at the first, low and mid at the first, and mid at the last. Okay, this is my starting condition. What is my exit condition? Till my mid remains less than and equal to high. That means it is not equal to, till it is not greater than high. Till then loop continues. Okay, till then loop continues. So my loop will continue till then. I'm declaring 3 cases that if my mid equal to 0, I'll just swap it with the lowest index, that is on the left hand side. And what I'll do is I'll increment the count of low as well as I'll increment the count of mid. Okay, if my number is equal to 1, I'll just put the bag down. And move to the next bag. That is what I'm doing. Else, if my number is 2, then I'll just swap it on the right hand side. and I'll decrement the value of height. I'll decrement the value of height. So as we have to do it in place, we don't have to return anything, void is there. Okay, so I'll just try to run. If there any error comes, then we'll try to debug it together. Okay, okay, so no errors coming. Just try to submit it. Okay, so answer is submitted. Okay, beats 100% of users with C++. Okay, okay. So if I see the time complexity of this question, time complexity of this question, as you can see that I am running one loop, as I am running only one loop in which I'm checking all the three conditions, and if 0 I am putting it on the left hand side, if 1 putting it right here, and if 2 I'm putting it on the right hand side. Okay, so the loop is running for only once. One mid comes from 0 to somewhere in between, and high comes from last position from to somewhere in between. So the total iteration becomes O of n. And what about the space complexity? As I'm not using any extra space, I am using only variables, that is the constant space, so it becomes O of 1. So this was all about Dutch national flag algorithm. Dutch national flag algorithm. Dutch national flag algorithm. So this way we can sort three colors, three numbers, three colors, all as you can say, as you like it. Okay, as you like it, anything you can say anything. We are just sorting it. Okay, so if I want to summarize the solution, I'll just, if I have 0, I'll put on the left hand side. If I have 2, I'll put on the right hand side. If I have 1, I'll put it here only. Okay, and for giving something, I'll have to take back something, so there would be an exchange on both the sides. If I am giving it here only, I don't have to do any exchange. Okay, so this was the summary of the solution. This was the solution of the question sort colors. Okay, I hope you liked it. If you have any suggestions, if you have any comments, you can just mention it in the comment section. You will get the problem link as well as the submission link in the description, and I'll also add the timestamps. Okay, so if you like the solution, do share, like, subscribe, and okay, bye bye, tata, have a good day.